Okay, so today we're going to be looking at types of waves. But before we start with the chapter, there are a few words that you need to be familiar with. Okay, some of the words are written here. And the first one is propagation. So you need to know that propagation means is the way in which wave travel. So whichever direction that the wave travel. And then the second word is oscillation. And oscillation is, in other words, vibrations, or basically repetitive movement or motions with times. And then wavefront, this is very important because you'll be looking at wave in a form of a wavefront that will be something like this. Especially when it comes to when we learn about water waves later on. So basically it's another way of showing how waves look like. So mostly you want to represent wave movement. So this is a plane wave when you draw it on a straight line, but we're going to get to that further when we learn about water wave later on. And then next one is wave speed. So speed is just speed, so it's how fast the wave travel in the matter of time, but it only applies to the wave. So for example, light wave, they travel at 3 times 10 to the power of 8 meter per second, and the unit is still meter per second. And then for longitudinal wave, there are two things or two words that apply to them. The first one is compression and the second one is rarefaction. And compression is the region where particles are closest together. So if you look at a slinky, then this area here will be the compression. And then the rarefaction is where the particles are further apart. So this area here will be the rarefaction. And then next up is pitch. Okay. So pitch is basically due to frequency. So it's the quality of the sound. So if the lower the frequency, then the lower the pitch. The higher the frequency, the higher the pitch. And then wavelength is the distance between two successive crests or trough. And we'll see this further when we have a look at the graph later on. And amplitude is the maximum displacement from equilibrium position. So I'll stress this further when we look at the graph later on. And period is the time taken for one full wave. So for a wave length like this, so the time taken for the wave to move from one successive to the next successive. So the time here will be the period. And it is often written with a capital T. And crest in a wave, now you can imagine ocean wave here. So this part here will be the crest, and the part here will be the trough. Okay, so those are the keywords that you need to learn when it comes to wave. So now let's move on to the more important part in today's video, is in terms of the types of wave. So there are two types of wave. The first one we call it transverse wave, and the second one is called the longitudinal wave. So let's look at the definition first off. Okay, so basically the difference between these two is the direction of their propagation, with opposing the oscillation of the vibration, or opposing the vibration basically. So for transverse wave, it is 90 degree. The direction and the propagation is 90 degree to each other. Longitudinal wave is parallel, right? So in terms of definition, you can write oscillation, or you can also write vibration if you want, or perpendicular, to the direction of propagation or direction of energy transfer. And then for longitudinal wave, well, oscillations are parallel to the direction of energy transfer or to the direction of propagation. Okay, so remember that you can write this as vibrations, and you can write energy transfer as propagation, and it will wind up being the same thing. Okay, so now let's look at an example of a transverse wave. So transverse wave, you can just imagine the sea or the water wave. and you also got light and earthquake. But earthquake can come in both longitudinal or transverse wave, and the same for slinky as well, because this depends on how you move it. So this is imagining that you make the slinky movement up and down. Okay, and then we can have a look at longitudinal wave. So the example, or the most important one, is sound. It could be earthquake as well, because it could come in both, and of course slinky. But when you move it forward and backward, so when you move it like that. And for transverse wave is when you move the slinky like this, and then the slinky will look like this, and here the slinky will look like this, right? Okay, so now we're going to look at the graph that we have to represent this wave. So there are two types of graph that is important for SPM syllabus. You've got on the top here is displacement time, so often written as ST, or sometimes DT. And then you also have displacement distance, D. Okay, so this on the x-axis is time, the difference between them, and and for displacement distance on the x-axis is distance. So what you have, the maximum displacement, if you look at the definition just now, so maximum displacement would mean the amplitude of the wave. So this will be amplitude. Here is also maximum, also we call them amplitude. And on the displacement distance graph, this one here and this one here is amplitude. Right? And then because this is time, so two successive crests and two successive trough would mean the period, because it is in the unit seconds. Right? So this is the period, doesn't matter where they are. And because here will be in the unit meter, sometimes nanometer, sometimes centimeter, sometimes micrometer, it doesn't matter as long as it's the unit for length. So the distance between two successive crests and two successive trough is the wavelength. Okay, so now we're going to have a look at some of the practice question that we have for SPM. Okay, for example, the question here, they gave you a graph. So first thing that you need to do is to have a look whether it is displacement time or displacement distance. So you can see here is displacement, and they give you the unit as well in centimeter. And here's the distance, so this is displacement distance. And lucky for you, because this question already show you what is represented by two successive crests and two successive trough, which is the lambda here, which represent wavelength. And then also written here as A, and shown to you that A is amplitude. So because but you need to know that this lambda here will be in centimeter. Okay, and that's a transverse wave. All right, so you can pause the video, try the questions, and come back later for the answer. Okay, so we all know from the definition that we've got from our keywords that the amplitude is the maximum displacement. So direction is important, so that's why we use the word displacement here instead of distance. Amplitude, you can sometimes call it as the amount of energy that the wave has. Okay, so and then the wavelength is the distance between two successive points. Points already mean the crest or the trough of the same phase. Okay. And then the period is the time taken, which is if from this graph you cannot find the time taken, you have to use the formula, which will be in our next video in terms of wave equation. And then the last one is the distance traveled in 1 second. Now that will be the distance traveled by the wave in 1 second. So next up, we're going to have a look at some of the past SPM question. This is from a trial SPM question. So they want to know which of these diagrams shows a longitudinal wave. So remember from the definition that longitudinal wave is parallel motion between the propagation and the direction of vibration. So we got light here, we got water, we got spring, and we got another spring. So you can pause the video, try the question, and come back later for the answer. So from the example that I gave you before, we know that light is transverse. And we know that water is also transverse wave. So these two will not be the answer. And then spring, it depends on the movement that it makes. So if it's moved up and down, then this is transverse. So then this must be the answer. As a summary, so first one is the words that you must get familiar with this topic, because this is kind of new for you if this is your first time. You should know propagation, which is the energy transfer. You should know oscillations, which is the vibrations. And I'm only going to write some of the most important things here that is new to you. You should know what is frequency, their definition, and also where to find them from a graph, which you can't, and then you have to use formula for that. Period, definition and where to find them in the graph. Wavelength, definition and where to find them on the graph as well. And last one is amplitude, also definition and where to find them on the graph, both displacement time and displacement distance graph. So second one, you've learned that there are two types of wave. You've got transverse and longitudinal. This one is perpendicular, this one is parallel. And third one is two types of graph. You've got displacement distance and displacement time. And here will be wavelength. Then here would be period, and both here will be amplitude. Okay, that's all for today. I'll see you in the next video.